Hi friends, welcome to a new episode of I Square. In the previous class, we have completed the chapter Real Numbers, and in this class, we are going to begin the new chapter called Polynomials. Many of you may have heard about polynomials. Some of who hasn't heard about polynomials, let me give you a brief introduction. Polynomials are just algebraic expression. But every algebraic expressions are not polynomials. So, polynomials are some special algebraic expression which is of the form an x raised to n plus an minus 1 x raised to n minus 1 plus an minus 2 x raised to n minus 2 plus etc. plus ax plus a naught, a1x plus a naught. So, a polynomial is nothing but any algebraic expression of the form an x raised to n plus an minus 1 x raised to n minus 1 etc. a naught, where there is a condition an cannot equal to 0 or an not is equal to 0. So, whenever an expression, an algebraic expression keeps these two conditions, we can say that the algebraic expression is nothing but a polynomial. Note that this n must be a whole number. So, we can have polynomial like that. Now, we shall check some examples. You have seen many expression of the form 2x plus 3, 5x plus 2, etc. In general, it is of the form ax plus b. See, this is also of the form this, where the highest power is 1 and the first coefficient is a and the constant term is b. Here the constant term is nothing but a naught. So, this is also a polynomial. Also, you may have seen expressions like 2x square 5 plus 5x plus 2 or 8x square plus 3x plus 3 etc. These are also polynomials since the highest power of x is here is 2 and it is a whole number and it also keeps a form like this. So, any algebraic expression which keeps the form like this, we can say that algebraic expression is nothing but a polynomial. Now, we are going to denote this polynomial by p of x. So, any polynomial can be denoted by p of x and it can be expressed like this, and we can say that any expression is of the form this is a polynomial and we can denote it as p of x and we read it as polynomial in the variable x. Polynomial in the variable x. So, polynomial in the variable x is an algebraic expression which is of the form an x raised to n plus an minus 1 x raised to n minus 1 plus an minus 2 x raised to n minus 2 etc. plus a naught. Is it clear? Now, we may have various kinds of polynomials. For example, see, here we have got a polynomial. In this example, we got another polynomial. Obviously, there is a notable difference between these two. Here we have only 2 terms, whereas we have 3 terms. Also, the highest power of x is 1. Here the highest power of x is 2. By such characteristic, we can distinguish various kinds of polynomial. For example, in this example, the highest power of the polynomial is or the variable is 1, whereas in this example, the highest power of the variable is 2. By the highest power of the variable, we distinguishes various polynomials, and we say the highest power of the polynomial or the highest power of the variable by a name, that is the degree of the polynomial. So, the degree of the polynomial is nothing but the highest power of the variable in the algebraic expression or in the polynomial. So, the highest power of the variable can be named as the degree of the polynomial. So, here the degree of the polynomial is nothing but 1. Here the degree of the polynomial is nothing but 2. Similarly, we can have various kinds of polynomial. For example, in 3x cube plus 8x square plus 4x plus 2. Here the highest power of the variable is 3 and we can say that the degree of the polynomial is 3. So I said that we can distinguish various polynomials by the power of the highest power of the variable. Now we are going to name each polynomial by the highest power of the variable. A polynomial with degree 1 is called a first degree polynomial. So a first degree polynomial is nothing but a polynomial with degree 1. So we can give various examples for that. 2x plus 3. Here the degree of the polynomial is 1. Hence it is a first degree polynomial. 8x plus 4. Here the degree of the polynomial is 1. Hence it is a first degree polynomial. Or simply 2x, 5x, etc. are all first degree polynomials. Clear? Now a polynomial with degree 2 can be named as second degree polynomial. So any polynomial with degree 2 can be named as second degree polynomial. So we can have various examples like 2x square plus 8x plus 5, 10x square plus 5x, 9x square plus 1, etc. In all these examples, the highest power of the variable is 2. Hence we can say that the degree of the polynomial is 2, and hence we can name such polynomials by second degree polynomial. Similarly, we can also define a third degree polynomial. What is the definition of the third degree polynomial? Any polynomial with degree 3. We can give various kinds of examples for that. For example, 3x cube plus 4x square. Here the highest power of the variable is 3. It is a third degree polynomial. Similarly, we can give various examples. Also, we give another name to all these kinds of polynomial. For a first degree polynomial, we can also call such polynomials as linear polynomials. So linear polynomials are nothing but those polynomials with degree 1. So any polynomial with degree 1 is also named as linear polynomials. Now a second degree polynomial can also be named as quadratic polynomial. So quadratic polynomials are nothing but polynomials with degree 2. So a second degree polynomial is also called as quadratic polynomial, whereas a third degree polynomial can also be named as cubic polynomial. So we got several different names. A first degree polynomial can be named as linear polynomial, second degree polynomial can be named as quadratic polynomial, third degree polynomial can be named as cubic polynomial. Now we are going to find the value of the polynomial. So our next aim is to define value of the polynomial. Now we know various kinds of polynomials like first degree polynomial, second degree polynomial, third degree polynomial, which are also can be called as linear polynomials, quadratic polynomials and cubic polynomials respectively. Okay, now value of the polynomial. Let p of x be a polynomial. I said that any polynomial can be named as p of x, which can be read as polynomial in the variable x or polynomial in x. So let p of x be a polynomial. Now let the value of the polynomial p of x at x equal to 2 can be obtained by substituting x equal to 2 in the algebraic expression. That is, suppose that p of x is equal to 3x plus 5. Just suppose that p of x is equal to 3x plus 5. Then p of 2 is equal to, substitute x equal to 2 in this expression, 3 into 2 plus 5, which is equal to 6 plus 5 equal to 11. That is, the value of the polynomial at the point 2 is equal to 11. Clear? Or we can find p of 3. P of 3 equal to 3 into 3 plus 5 equal to 9 plus 5 equal to 14. Hence we can say that the value of the polynomial at x equal to 3 is equal to 14. Similarly, if p of x is equal to 5x square plus 2x plus 2, we can also find the value of the polynomial here. Suppose x is equal to 5, then p of 5 is equal to 5 into 5 square plus 2 into 5 plus 2. 5 into 5 plus 5 square, 5 into 25 equal to 125 plus 2 into 5, 10 plus 2 equal to 137. Similarly, we can always find the value of the polynomial for any real number. Just substitute the value for x in the algebraic expression, then we will get the value of the polynomial at a particular value. Clear? We said that any polynomial whose algebraic expression is given, we can find the value of the polynomial at any point. Clear? Now, 0 of a polynomial. If a value gives the value of if a real number gives, when substituted, gives the algebraic expression equal to 0, then we can say it is a 0 of a polynomial. For example, suppose p of x equal to the polynomial. Our polynomial be p of x. Let's suppose that p of x is our polynomial. Then to find the 0 of a polynomial, just substitute different values for x. That is when we can substitute x equal to 1, x equal to 2, x equal to 3, etc. We can always substitute and substitute like that. So at some point when suppose that when we substitute x equal to 2, p of 2 is got as 0, p of 2 equal to 0. Then we can say that x equal to 2 is a 0 of the polynomial. Or when we substituted, we got p of 5 is equal to 0. Then we can say that 5 is a 0 of the polynomial. Is it clear? We can check by some example. Suppose that p of x is equal to 2x minus 2. Since it is of the form a(n)x raised to n plus etc. a0, we can say that this is a polynomial and the degree of the polynomial equal to 1. Suppose that we are going to find p of 2. What is p of 2? 2 into 2 minus 2 equal to 2. Clear? And now we are going to find p of 3. What is p of 3? 2 into 3 minus 2 equal to 6 minus 2 equal to 4. Now we are going to find p of 1. Suppose we are going to find p of 1. P of 1 is equal to 2 into 1 minus 2 equal to 0. See, when we substituted 2, we get 2. When we substituted 3, we got 4, not 0. But when we substituted 1 instead of x, we got 0. Hence, we can say that 1 is a 0 of the polynomial. Is it clear? That is, 1 is a 0 of 2x minus 2. P of x is equal to 2x minus 2. Because when we substituted 1 instead of x, it will result in the value 0. The value of the polynomial will become 0. So 0 of any polynomial can be evaluated easily. Just look that if we substitute, it will give 0 or not. If it gives us 0, then we can clearly say that that is a 0 of a polynomial, of the polynomial. Similarly, for second degree polynomial, we can find out 0. For third degree polynomial, we can always evaluate the 0 of the polynomial. Is it clear? So in this section, we are going to find the 0 of a linear polynomial. We know that a linear polynomial is a polynomial with degree 1 or highest power of the variable equal to 1. So now we are in a position to find the 0 of a linear polynomial. Let p of x is equal to ax plus b, which is the general form of a linear polynomial. Since the power of x equal to 1 here, it will be a first degree polynomial or a linear polynomial. It is clear, right? Now p of x equal to this. Let k be a 0 of the polynomial. That is, when we substitute k to p of x, we get the value of the polynomial as 0. Isn't it? So we have p of k is equal to a k plus b, which must be equal to 0. When we substituted k instead of x, we must get 0. But when we substitute k instead of it, that means ax plus b will change to ak plus b. That is, ak plus b must be equal to 0. Equal to 0. Now, ak plus b equal to 0. So we have ak is equal to minus b, k is equal to minus b by a. See, this a will go to the denominator of b, so we get k is equal to minus b by a. So k is equal to minus b by a. What does that mean? See, we chose k as the 0 of the polynomial p of x, and when we substituted k, we got the value of k as minus b by a. That is, minus b by a will be a 0 of ax plus b. See, k is equal to minus b by a. So instead of k, now we can easily locate the 0 as minus b by a. So for a polynomial ax plus b, the 0 will be minus b by a. Just always remember that for any linear polynomial of the form ax plus b, the 0 will be minus b by a, which means that when we substitute minus b by a to this polynomial, this will be 0. Let us check it out. Let our polynomial equal to 3x plus 5. Right, our polynomial equal to 3x plus 5. Whereas a equal to 3 here, b equal to 5 here. So the 0 will be minus b by a, b 5, a 3. So minus 5 by 3 will be the 0. Let us check it out. P of minus 5 by 3 equal to 3 into minus 5 by 3 plus 5. Right? P of minus 5 by 3. We substituted minus 5 by 3 instead of x. How we got minus 5 by 3? Because we derived that if k is a 0 of this polynomial, then k is equal to minus b by a. That is, any 0 of a polynomial of the form this as of the form minus b by a. Here our polynomial is also in the form ax plus b, where a equal to 3 and b equal to 5. So the 0 will be minus 5 by 3. Therefore, p of minus 5 by 3 is we got like this. Now 3 and 3 can be cancelled, so it will become minus 5 plus 5 equal to 0. See, now we can easily evaluate this 0 of any linear polynomial. So 0 of any linear polynomial can be evaluated. What should we do? For any linear polynomial of the form ax plus b, the 0 will be minus b by a. So now we can find the 0 of any linear polynomial. Suppose that you are given with linear polynomials like this, then the zeros. The 0 of 8x plus 3 is nothing but 3y minus 3 by 8. The 0 of this is equal to minus of minus 1 by 2. Since here b is equal to minus 1, minus b by a, minus of this equal to 1 by 2. The 0 of this, b equal to 5, a equal to 11, minus 5 by 11. The 0 of this, b equal to 20, a equal to 2, minus 20 by 2. Similarly, you can now find the 0 of any linear polynomial. Just remember that if p of x equal to ax plus b, then 0 is equal to nothing but minus b by a, where b is the constant term, a is the coefficient of x. Is it clear? So I hope you understood the process of finding the 0 of any linear polynomial. Now you can do many examples from your textbook, guides, anywhere to find the 0 of any linear polynomial. Just remember that the 0 of any linear polynomial is nothing but minus b by a. So if you haven't subscribed our channel yet, please subscribe and wait for our next video. We will come up with new tips and tricks to deal with complicated problems. Thanks for watching.